Okay, in the today's lecture we are going to see RL series circuit. So as you can see in the circuit diagram, there are two components connected in series, resistor R and inductor L, and voltage, supply voltage is connected across it. So given supply voltage V is equal to Vm sine of 2 pi ft. So due to the supply voltage connected across resistor R and inductor L, the current flows through the circuit is instantaneous current I. So as a current flows through the resistor R, there is a voltage drop across resistor R is the VR. Also that same instantaneous current I that flows through the inductor L, voltage drop across inductor L is the VL. So in the given circuit there are only two components, resistor R and inductor L, connected across supply voltage V. V is equal to Vm sine of 2 pi ft. That's why it is called as the RL series circuit. So as per Ohm's law, we can determine instantaneous voltage I is equal to V upon R. So all of you know that Ohm's law. According to the Ohm's law, we can determine the current flows through the any circuit, and Ohm's law says that the current flows through any circuit is given by the supply voltage V divided by resistance of that electrical circuit. So that is the standard Ohm's equation, I is equal to V upon R. So if you know the I is equal to V upon R, then we can determine V is equal to I into R. So on the right hand side, R is the denominator. So if you take it to the left hand side, it becomes the multiplier to the current I. So V is equal to I into R. So we can say that voltage can be determined by multiplying current I and resistance R. In the same manner, we know that the current flows through the resistor R is the I, and voltage across resistor R is the VR. So if you know the I and VR, we can determine, if you know the value of resistor R and the value of instantaneous current I, we can determine voltage VR is equal to I into R. Okay, so voltage across resistor VR we can determine by simply multiplying current I to the value of resistance R. So VR is equal to I into R. In the same manner, we can determine the voltage across inductor VL. If you know the value of reactance XL and the value of instantaneous current flows through the inductor L is I, then we simply multiply current I into XL, we get the VL. So VL is equal to I into XL. So we have three formulas given in the slide, which is standard Ohm's law, I is equal to V upon R. We can determine V is equal to I into R. So in the same manner, we can determine voltage VR is equal to I into R and voltage VL is equal to I into XL. So here XL is the inductive reactance. And what is inductive reactance? Inductive reactance is the opposition offered by inductor to flow of alternating current. Okay, so which is called as the inductive reactance XL. So we have just understand what is circuit diagram. It has only two components, R and L, connected in series. That's why it is called as the RL series circuit. And we have seen the voltage drop across R is the VR, voltage drop across L is the VL. Instantaneous current flows through the this whole circuit is I, and we have determined the voltage VR is equal to I into R and voltage VL is equal to I into XL. So now our aim is to determine the phasor diagram for the instantaneous current flows through the circuit I and supply voltage V. Okay, so we have to determine, or we have to plot the phasor diagram for the supply voltage V and the supply current I. So before plotting a resultant supply voltage V and resultant supply current I phasor diagram, we have to plot individual phasor diagram for resistor R and inductor L. So you can see there are three phasor diagrams on the screen. On the left hand side there are two phasor diagrams. Topmost phasor diagram is for the resistor R and bottom one is the inductor L, and on the right hand side there is a resultant phasor diagram which is for supply current I, which is given on the reference axis, and supply voltage V. Okay, and there is an angle between V and I is the theta. So first we have to draw the individual phasor diagram for resistor R and inductor L. So we can see the first phasor diagram given in the left hand side, okay. So which is for the resistor R, and it shows that it is the phasor diagram for resistor, the current flows through the resistor which is IR, and voltage across the resistor which is the VR. So we have to draw the phasor diagram for resistor, for the resistor which is the voltage across resistor VR, and current flows through the resistor is IR. So if we know that what is phasor diagram. For phasor diagram is just a straight line, one arrow indicated at one side which indicates the direction of rotation, and length of phasor equal to the peak value of sinusoidal quantity. So how to draw the phasor diagram? First draw the reference axis, okay. So you can see in the first phasor diagram there is a reference axis drawn, okay. And if you want to draw the more than one phasor diagram, then you have to draw any one phasor on the reference axis. So how which phasor we can draw on the reference axis? So we can draw the phasor diagram which is common to all. So if you see the current I, which is the same for resistor R and inductor L. So whatever is the instantaneous current flows through the circuit is I, that same current flows through the resistor R which is IR, and that same current is flows through the inductor L which is IL. So there is a common current flows through the resistor R and inductor L, just notation is different. So total supply current is I, voltage current flows through the resistor R is IR, and current flows through the inductor L is IL. So all three currents are the common current which is the I. So we can draw the common quantity on the reference axis, and common among all these three components, among all these three circuit components, which is the whole electrical circuit, RL series circuit, individual component R and individual component L, which one is the common current I. So just notation is different. For the resistance current is IR, and for inductance current is the IL. So for the phasor diagram for resistor R, we have drawn the reference axis, and we can see on the reference axis there is a phasor for current is the IR, okay. Look at the first phasor diagram on the reference axis. First we can draw the common among all these two components which is the current I, and we have drawn the phasor for current which is IR on the reference axis. Now we can draw the phasor diagram for voltage across resistor which is the VR, okay. So what is the relation between IR and VR? Okay. So if we apply the voltage across resistor R, if we apply the voltage across resistor R, and then the current flows through the resistor I, which will be in the same phase as the voltage across resistor R. So supply voltage V or a voltage across the resistor VR, and current flows through the resistor IR, both are in same phase, okay. So there is no phase difference between voltage VR and current IR. So we can draw on the same axis VR, okay. So we can draw the phasor for voltage VR on the same axis. So because there is no phase difference between voltage across resistor VR and the current flows through the resistor IR, so both are in same phase. So both are drawn on the same axis, or both are drawn on the reference axis, because there is no phase difference. Now we are going to see the phasor diagram for the voltage across inductor VL and current flows through the inductor which is IL. So phasor diagram for VL and IL, which is given on the left hand side, okay, which is the second phasor diagram, okay. So the common between R and L is the current I, okay. Just notation is different, IL and IR. So on the reference axis, the phasor diagram drawn on the reference axis is the IL, okay. So now we are going to draw the phasor diagram for the VL. So as we know that if we apply the voltage across the inductor, if we apply the alternating voltage across the inductor, current flows through the inductor lags behind voltage VL by 90 degree. So current lags voltage by 90 degree, or voltage VL leads current by 90 degree. So if the current drawn on the x-axis, then we can draw the voltage VL on the y-axis, because there is a 90 degree phase shift between voltage and current. Current lags VL by 90 degree, or voltage leads current by 90 degree. Okay, so top one phasor diagram is for the resistor and bottom one is for the inductor. Now we can merge these two phasor diagram, okay, together. So on the right hand side there is a merged phasor diagram for resistor R and inductor L. So on the reference axis the phasor diagram drawn is the current I, because it is common in between resistor R and inductor L. Okay, on the same axis phasor diagram drawn which is the VR, because there is a zero phase difference between VR and I. Okay, on the y axis there is a phasor diagram drawn which is the VL. Okay, because we have merged these two phasor diagrams, so we have to draw the resultant phasor diagram for the supply voltage V. So we have two different phasor diagrams for voltages VR on the x axis and VL on the y axis. So resultant phasor diagram is in between the voltage phasor diagram VR and voltage phasor diagram VL. Okay, so there is a resultant phasor diagram V which is in between VL and VR. That resultant phasor for voltage, supply voltage V, leads current I by theta degree. So that is the resultant phasor diagram for supply voltage V and supply current I. So if you see the supply voltage V and supply current I, there is a theta phase difference between V and I. So current lags supply voltage V by theta degree. Okay, that is the resultant phasor diagram. So how we get that resultant phasor diagram? First we have to draw the phasor diagram for resistor R, which is for IR and VR. Then draw the phasor diagram for IL and VL. Merge these two phasor diagrams and we get the phasor diagram for V and I. Next one is the voltage and current waveforms. So as you see in the phasor diagram, there is a theta phase difference between voltage V and current I. So current I lags voltage V by theta degree. Okay, so if we draw the voltage waveform, then while drawing the current waveform we have to consider the phase difference is theta. So current I lags voltage V by theta degree. So you can see that phase difference in the waveforms too. Okay, so next one is the voltage and current equation. So voltage equation is given in the first sentence, V is equal to Vm sin of 2 pi f t. Then how to write the current equation? Before writing current equation we have to consider the phase difference between voltage V and current I. So current I lags voltage V by 90 degree. That's why current equation becomes I is equal to Im sin of 2 pi f t minus of theta. Next one is the impedance and impedance triangle. So as we know that the impedance, what is impedance? Impedance is the opposition offered by resistor, capacitor and inductor to flow of alternating current. Okay, so how much opposition offered by resistor, capacitor and inductor to flow of alternating current, that amount of opposition is called as the impedance and its notation is Z. So impedance can be written in two forms, rectangular form and polar form. So in a rectangular form Z is equal to R plus Jx and X is the XL minus XC. So there is absence of capacitor, so XC becomes 0. So Z is equal to R plus JXL, unit is ohm. In polar form, Z is equal to mod of Z at the angle of theta. So mod of Z is equal to under root of R square plus X is XL minus XC square. So XC is 0. So under root of R square plus XL square. Theta is tan inverse of X by R. X is nothing but the XL minus XC. XC is 0. So XC is replaced with XL only. So theta is equal to tan inverse of XL by R. Z is equal to under root of R square plus XL square at the angle of tan inverse of XL by R degree ohm. So in the first slide we have drawn the phasor diagram for supply voltage V and supply current I. So in that phasor diagram we can see there is a voltage triangle. One side is supply voltage V, one side is supply voltage across resistor VR and one side is supply voltage across inductor VL. So there are three sides V, VR and VL and it is the right angle triangle, and which is drawn here, which is the voltage triangle. So what is the value of supply voltage? V is equal to I into Z. What is the value of voltage across resistor, which is given equation I into R, and what is the value of voltage across inductor VL is equal to I into XL. So in this voltage triangle, three sides are V, VL and VR, V is equal to I into Z, VL is equal to I into XL, and VR is equal to I into R. If we divide each side of voltage triangle by current I, then we get the impedance triangle Z, XL and R. As I is equal to V by R is equal to V by Z, V by I. So Ohm's law is I is equal to V by R, so R is equal to V by I. So if we divide each side of voltage triangle with the current I, we get the impedance triangle R, Z and XL. So active power in RL series circuit. So active power is power consumed by load, and load is R and L. So amount of power which is consumed by R and L both together, which is given by P is equal to V into I cos of theta. So energy consumed by R and L component is determined the equation E is equal to power into time. So in this RL series circuit, we have seen the circuit diagram which has only two components R and L connected in series across it. That's why it is called as the RL series circuit. Supply voltage is V is equal to Vm sin of 2 pi of t. Voltage across R is VR, voltage across L is VL, supply current is I. So I is equal to V by R, VR is equal to I into R, VL is equal to I into XL. So we have drawn the resultant phasor diagram which is for the V and I, and in the phasor diagram we can see that V is leading and I is lagging by theta degree. So how we have drawn this phasor diagram? First we have drawn the individual phasor diagram for resistor R and L, merge both together to get the resultant phasor diagram for supply voltage V and current I. So this is the waveforms for the supply voltage V and supply current I for RL series circuit. I is lagging by theta degree, and the equation for the voltage and current given here. The current equation shows that current lagging the voltage V by theta degree. So impedance is given in this slide, and with the this voltage triangle we get the impedance triangle by dividing each side by current, and this is the formula for active power and energy consumed by the RL series circuit. So with this we are going to stop here.